Tabulating data. Whenever you're collecting data, you will be expected to display it clearly in a table. The columns must be headed with the quantity and the units. This can be in words or in symbols, for example force/newtons or F/n. Don't put your units in brackets. Include columns for repeat readings and for any process data, such as mean values, square roots, etc. Make sure any raw data, that's data that you've actually measured, is given to the precision of the measuring instrument. This is often overlooked when using a metre rule, which generally has a precision of plus or minus 1 millimetre. So, for example, when quoting a length of, say, 20 centimetres, you must use 20.0 centimetres or 0.200 metres, as 20 centimetres alone, or 0.20 metres, is only to a precision of plus or minus 1 centimetre, and you will lose marks for this. As an example, we will look at a table for finding the time period of a simple pendulum for a range of lengths. We are asked to plot a graph of time period against the square root of the length. Even if you're not asked to, in an assessed practical you will be expected to take repeat readings. For a pendulum, you will reduce the percentage uncertainty by timing several swings and then dividing by the number of swings to get the time period for one swing. We need a column for the length of the pendulum, one for each of 3 repeats, one for the mean time for multiple swings, one for the time period for one swing, and then one for the calculation of the square root of the length. This is 7 columns overall. So this is our table with the first column here for our independent variable, the length, not forgetting the units of metres. Here I've given 7 different values. You must give at least 6, more if possible. This is my columns for my 3 separate readings of 20 swings, and then for calculating the mean of those 3 readings. The heading here covers all 4 columns with the units, but it does not cover this column, so this has its own units for the time for one swing. So this column will be found from our mean divided by 20. I then have a column for the time squared, as we were asked, in the units of seconds squared. So here are my first set of values, and these give a mean of 21.983333 seconds. But I can't quote this figure to more significant figures than these, and so I'll write 21.98 seconds. Dividing by 20 to find the time for 1 second gives a value of 1.09916 seconds. Again, I must go to the same number of significant figures, the same precision of measuring here, and I'll quote 1.10 seconds. Squaring this gives 1.21 seconds squared, which I can quote directly. My next set of readings give a mean of 25.4 seconds. Again, I must quote this to the same precision as these, so I'll write 25.40 seconds. I'll now complete the table.